This part of our discussion of California geology focuses on the major sedimentary rock units. Here's the map that you've seen before, and we're going to color 3 units this time. The Cretaceous sedimentary rocks we're going to color blue, the Tertiary sedimentary rocks orange, and the Quaternary sedimentary rocks yellow. It'll look something like this, if I can hide myself. So I've colored it blue, orange, and yellow here on the map, and I'm showing it to you separately from the igneous ones I did in the last map so that you can see where they're located. They kind of jump out at you. But I'm not asking you to print another map and make this a separate map. This should be added to the igneous units that you already colored on the previous map, so that in the end of all of this, you'll have one map with all of the units colored on it. So I just did this separate so that they would kind of be easy to pick out so you could see which ones you need to color. So the story of the sedimentary units in California is pretty simple compared to the igneous story we went through last time. I'm going to skip a lot of detail and mostly describe where these sedimentary rocks formed and a little bit about how they deformed. So I'm going to jump back to this picture from the previous discussion of igneous rocks and the time of Mesozoic subduction. If you recall, we have the Farallon plate coming in from the west, subducting beneath the North American plate in the east. We have all of these magma chambers solidifying and forming what's eventually going to be the Sierra Nevada batholiths of the Sierra Nevada mountains. And above we have the volcanic subduction arc that eventually gets eroded away. So out here is where I want to talk about sedimentation. This is where we have those blue rocks that we're going to color, the sedimentary rocks of the Cretaceous, which is the latter part of the Mesozoic. So these were marine sediments that were deposited obviously offshore below the ocean. So they consisted of limestones, carbonates, things that are deposited out in the marine environment, also shales, some sandstones and siltstones closer to the shoreline. And these are represented in blue. And that's it. We're going to just put those right there. I'm going to zoom in on this area, and we're going to leave this region to the east out of the picture so we can focus on a little more detail over at the plate boundary. As time went on and we moved into the Cenozoic, this plate boundary started to have more things happen to it. And I'm going to go into the detail when I get to the third California map description of metamorphic rocks. But right now we have a bulge occurring, an uplift, and all kinds of metamorphism occurring in the region that's eventually going to be the Coast Ranges. This is where the Great Valley is going to be, and the Sierra Nevadas are off the picture to the right. So in the blue we have those Cretaceous sedimentary rocks, and now I'm adding the Tertiary sedimentary rocks. I've put sea level in here to indicate that, again, these are mostly marine. I've also shown that not only do we have them forming offshore of California over the subduction zone, but also inland where the future Great Valley is going to be. Notice that there is a curve here. I'm trying to indicate that this region is actively curving because there is compression. And remember, when we compress things, we create folds. And in this case, that fold is making a syncline. And so we wind up folding these into a syncline. I'm definitely simplifying this. There's a lot more complication going on here. And so this is the orange unit that you're going to color on your map. After that, we go on to the sedimentation of the Quaternary units. And those go on top of the orange ones. These are the yellow ones. And again, we have more folding out in this area. I didn't really change the diagram. I didn't want to make your diagrams too difficult to draw. But we have even more compression and more folding into this U shape. This is all underwater, as I've shown, which is not completely true. We also had alluvial fan deposition coming from the Sierra Nevadas over here, and if you recall, alluvial fans are a terrestrial environment. They form gravels, which will eventually become conglomerates, and so those are also involved in what that yellow unit is. So that yellow unit is marine as well as continental sedimentary rocks. Now, if you remember what the geologic map looks like, these units are not all spread out nice and evenly on the map. If you look here, the yellow part is pretty coherent, the youngest unit in the Great Valley, but there are pieces of it down here and the orange and blue units are certainly sliced and diced. And that's because the San Andreas Fault System, which is much younger than most of these rock units, has really split up these units and translated them all over the state. So today, they don't look much like a coherent whole, although that's how they started, like this. So if we think about what this might look like today, going back to the broader picture where we include the Sierra Nevada mountains of today, the Owens Valley, the Basin and Range Extension, this would be the region that we were just looking at. We have the Great Valley with the sediments that are present today, and then we have the Coast Ranges, and these dark brown lines are the vertical strike-slip faults of the San Andreas strike-slip fault system, which of course is part of the Pacific North American plate boundary. And so what I've done is I've tried to show these rock units how they've been offset by that system, folded, tilted, and disturbed. In the metamorphic discussion, which is the next video, we're going to talk about all this white stuff down here. What is all of this lying on top of? And when we look at the geologic map here, there's a bunch of units that we haven't looked at yet that are all kind of pinched in there. So what are those? And those are related to the metamorphic rock story. So you have your sedimentary rock story and your igneous rock story. Coming up next is metamorphic rocks.